All right, so we're going to be looking today at the different types of chemical reactions. And I have listed right here the different types of chemical reactions that we have. So we have synthesis, decomposition, single replacement, double replacement, and combustion. You need to be familiar with these five, and you need to be able to identify them if you're given an equation. So let's look at how we do that. And I don't know why this is so slow. Wow. Oh, so maybe blank one got in there somehow. So, all right, so for synthesis, you have two or more reactants combined to form a single product. So the big thing is that you get a single product. So for honors chemistry, if there's a single product, it's going to be synthesis. All right? So here we see, here's our single product right here. So we have sodium and chlorine combined to make sodium chloride, a single product. That's synthesis. The opposite of synthesis is decomposition. So basically you have one reactant. Here's our one reactant. And what it does is it disintegrates, it decomposes, it breaks apart, and you get two or more products, right? One, two. You got to get at least two products for this to be decomposition. So synthesis and decomposition are the opposite. Single replacement, you got atoms of one element replacing atoms of another element in a compound. Basically, when you look, the reactants are an element plus a compound. So you got A plus B, C, and then what happens is A and B switch places. So you get AC makes a new compound, and you get B as an element. Or it looks like this. So we have aluminum plus copper chloride. So aluminum is going to replace the metal in the compound. So aluminum and copper switch places, and then you get aluminum chloride plus copper. And a lot of people will go, well, there's two chlorines here, there's three there. How's that happen? Well, when aluminum and chlorine form a compound, you got to remember aluminum is +3 and chloride is -1. So this is the formula for aluminum chloride. So the subscripts may not be the same on both sides of the equation because aluminum forms an ion and bonds to chloride, copper forms an element. So you got to rewrite the products. So most of these single replacement reactions are basically a metal replaces another metal or a non-metal replaces another non-metal. All right, for double replacement, you have two positive ions that will switch with each other to form two new compounds, or if you're more of a glass half empty person, two negative ions switch places. So AB plus CD, A and C switch places to give CD and AD. So in other words, if we had calcium chloride plus sodium carbonate, right? Here's our two metals. The two metals switch places, and then over here we get calcium carbonate and sodium chloride. And when they switch places, what you have to do is you have to rewrite those formulas. So those formulas are gotten from writing the positive ion, negative ion, and then you crisscross to get the formula. All right? So that's double replacement. And the easiest way to recognize double replacement is basically you have a compound plus a compound. And then the last type of reaction we have is what's called a combustion reaction. It's a special type of reaction in which you have a hydrocarbon. So here's our hydrocarbon. Hydrocarbon means hydrogen and carbon. So these are things you can burn, like fuel, gasoline, natural gas, wood. And to burn things, to make a flame, what you need oxygen. And then the products you are going to get in this reaction are always water and carbon dioxide. So if you see a reaction, it's got oxygen as a reactant, and you got water and carbon dioxide as products, then it's going to be a combustion reaction. All right, so how do you identify these types? And we're going to go through this quickly. So you look, if it's got oxygen, carbon dioxide, and water, it's got to be combustion. Do two or more reactants combine to form a single product? And the key thing here is single product. If you have a single product, it's going to be synthesis. Does a single reactant break apart to form two or more products? So single reactant is the key here. It's the opposite of synthesis. It's decomposition. All right. Are there any elements in the equation? Basically, do you have a compound plus a single element? If you have a compound plus an element, it's going to be single replacement. And then the only thing that's left is a double replacement, which is going to be a compound plus a compound. The positive ion switch places. So let's look at some examples. So let's look here. So we got one reactant making several products. So that's our clue. So look, that's our first question. If you got one reactant, it's going to be decomposition. All right, let's look at this one. What's our clue for this one? It's got water, carbon dioxide, and oxygen. So you need to know that means it's combustion. All right, so look, we don't have a single reactant. We don't have a single product. We don't have carbon dioxide, water, and oxygen, so it's not combustion, synthesis, or decomposition. We don't have an element plus a compound, so it's not single replacement. So this is double replacement. All right, we got two compounds reacting to form two new compounds. All right, let's look at this. So what's our big clue for this one? Well, we have a single product. So if you got a single product, we have several reactants combining to form a single product. It will be a synthesis reaction. All right, let's look at this one. It's not combustion. It's not synthesis. It's not decomposition. And then look, we have an element plus a compound. So an element plus a compound is not double replacement. This is single replacement. Magnesium is a single element, so this is single replacement. So that should help you with this. Make sure you get this down in your notes. If you need any help, come and see me.